Okay, this is number 1 off of your section 5.1 worksheet. We're going to use the properties of logarithms to expand the logarithmic expression. So remember, properties of logarithms say that if I have division can be rewritten as subtraction. Um, and we haven't really talked about this in class, but if I have natural log, the base for natural log is the number e. I know you wrote down the number e in your notes. If I have what I will call common log, L-O-G, so natural log, this is common log, L-O-G, the base is 10 because they won't ever show what the base actually is. But if it's natural log, it's e. L-O-G is 10. Okay, so number 1, I'm going to write natural log of x, and instead of division, it's going to be minus natural log of 4. Okay, that's my answer for that one. On part B, I'm going to write it down here. This can be rewritten as x to the 5 halves. So a property, one of our properties says that if I have an exponent, that exponent can be rewritten down in the front of my natural log. So that is going to be, did I just write that down wrong? 5? No. Okay, so 5 halves, natural log of x. And it's 5 halves because 2 is my index number, so x to the 5th, and the square root of that can be written like this. Part C, I have natural log x. They're multiplying, so it's going to be plus natural log of y minus natural log of z. And part D, that's my answer for C. Part D, this is all being multiplied, so I have natural log of x plus natural log of y plus natural log of z. So we like these, they're not too bad. Okay, part E, I'm going to write E over here. This can be rewritten as x minus 1 over x to the 1/2. Okay, so there's several ways you could write this. This could also mean natural log of x minus 1 to the 1/2 over x to the 1/2. So if I do it that way, I'm going to bring down my exponent. So I have 1/2 natural log of x minus 1. It's a division problem, so I'm going to say minus, bring down my exponent, 1/2 natural log of x. So that's number 1. Number 2, part A, and I'm going to write these down here. Write the expression as a logarithm of a single quantity, so that means I'm going to write log 1 time or natural log 1 time. So part A, I have natural log of x minus 2, and it says minus, so I know that it's going to be division, x plus 2. Part B, all right, this 3 used to be an exponent, so I can write natural log of x to the 3rd. It says plus, so I'm going to multiply. Natural log of y, I've already written my natural log, so I'm just going to write y, and this 2 used to be an exponent. Minus, so that means divide, z to the 4th. And that's my answer. Part C, I'm going to write it out here. Okay, part C, let's see what we have. So I know this whole thing is to the 1/3 power, because this 1/3 is has everything in parentheses, so I'm going to put that at the very end. So I know whatever I have is going to be to the 1/3 power. Then I have natural log of x plus 3 with this 2 in front, so I know I have natural log x plus 3, and that's being squared, plus, so that means times, x minus x squared minus 1. I'm doing these pretty quickly, so if I make a mistake and you catch it, let me know tomorrow in class and we'll look at it again. All right, part D. Okay, so I have my natural log. This whole thing is going to be squared because of this 2 out in front. So I'm going to write natural log. I have x. Minus means divide x plus 1 minus x minus 1 again. I'm going to have to check mine on that. And that whole thing is being squared. I'm going to look at that again in class tomorrow. And the last one, e. Natural log of 3 squared, because this 2 used to be an exponent, divided by x squared plus 1, but that was to the 1/2 power. So that's actually natural log of 9 over x squared plus 1. I could write it like that. Okay. So that's number 2. And again, I'm going to look at part D again. I think I may have written that wrong. All right, so let's look at number 3. So number 3, sketch the graph of the function and state its domain. So f of x equals 2 natural log of x. So you're supposed to sketch this, and it says copy the graph to scale on this worksheet, so I need to know what your scale is. Okay, and in your notes, you're supposed to write down what the domain of just f of x equals natural log of x. Okay, if I were to just graph this, and I don't have just that graph, but my domain or my x values start at 0 and go to infinity. Okay, so x is greater than or equal to 0. My range, even though it looks like it stops here, range, remember, is how far down, how far up, or your y values. It goes, and it gets so close because there's that, it's never going to have negative x values. Okay, so my range is actually all reals, or negative infinity to infinity. Okay, so unless they shift this graph over, that's going to be my domain and range every time. So here's the graph of 2 natural log of x. All right, I could do a table of values for this, but again, it wants the domain. My domain for 2 natural log of x does not change. My x's all have to be greater than 0. So let's look at number 4. Sketch the graph of the function and state its domain. F of x equals the natural log of absolute value of x. Here's the graph. Okay, so on this, my domain, which is our x values, this time it's all x values. Negative infinity to infinity, or I could just say all reals. Okay, and I'm going to stop there, and I'm going to do the last few. Well, let's go ahead and do 5. Sketch the graph. Here's the graph. Do you see that this 2 just took my original natural log of x graph and shifted it up 2 units? So my domain is still, oh, or else, x is greater than or equal to 0. Okay, my next one. Sketch the graph of the function and state its domain. This time, they've taken my natural log of x and they've shifted it to the left 2 units. Okay, so when I graph that, okay, they shifted it to the left. So instead of starting at 0, I'm going to start at 2. So x is greater than negative 2. And I need to go back and correct something. I had x is greater than or equal to 0. It cannot equal 0. It's just x is greater than 0. So that needs to be corrected on 5, 4, 4, we'll talk about that here in a minute. But this one also, x is greater than 0. It cannot equal 0. So that cannot equal 0. All right, so let's go back. That was number 6. And then we'll do 7 through 13 on a separate video.